Okay, we did several of these questions in class. These are from the topic 4 quiz. I've extended the quiz till Thursday, this Thursday, November 11th, which is a holiday, I think. We'll see. Anyway, I'm going to go through and work a couple of these because they involve either the law of sines. There's a few that will involve the law of cosines, and we will work through those as well. Again, I didn't expect this to be a trig class, but some of these they also have on the exam that we're going to be taking. So let's go through. So one of the things you're going to want in your notes is this law of sines, law of cosines. And the way this is working is if there is a large letter like A, that's an angle. So you'll see those usually are associated with a trig function. So angle A, angle B, angle C. Let me get my little epic pen out. It's a free download, so if you ever need to write on your screen, there it is. It's kind of a nice little feature. So double check all this. Okay, here we go. So the angles are large letters, A, B, and C. And in this case, C is a right angle. It doesn't necessarily have to be, though, for some of the things, well, actually for any of these. The little letters, A, B, and C, are lengths of the sides. Okay, so that for all of them, that's what it's going to be. Of course, we get in here and we've got different letters. What the law of sine says is that the angle opposite a side, so in this case big A, the angle big A and side of length A, that the ratio of the sine of the angle divided by the length of the side, that those are proportional for each of the sides, the angle and the sides. Whatever that is going to be similar. So actually for this one we did a little differently in class, but what we're able to do here is with each of these triangles we have angles, and this one's a 90, and we have a side length. So for this particular one we can set up a ratio and then we can figure out what C is. Okay, so since we want to find C, I'm going to start with that, the length of C. And now sine could be in top or in the bottom. That's just the way these ratios work, because if these ratios are equal to each other, then their reciprocals are also going to be equal to each other. So I'm going to start off with the reciprocal. I'm going to put side C, and I'm going to divide it by the sine of 45 degrees. That needs to be equal to the side length opposite the 90 degree that we have here, 6, divided by the sine of 90 degrees. Now it's just very helpful when we have a 90 degree angle, because sine of 90 is 1. The other thing for this, they want since they want our answers in square roots, we have to know the 3 special angles, and let me show you a way that you can get those. So the 3 special angles are 30 degrees. So if we have a unit circle, there is a 30 degree angle, a 45 degree angle, and a 60 degree angle. This gets us 60 degrees all the way up there. And what ends up happening is you'll see that the x coordinate, this is x equals 1 and y equals 0. The x coordinate starts out bigger than the y coordinate, and then it goes down. So what we get on the unit circle for trigonometry, and this one again, just put this in your notes, but you'll be able to create this. These coordinates, since it's dealing with half a circle, every coordinate is divided by 2. 45 is divided by 2, and the 60-degree angle is also divided by 2. And now the x goes from largest to smallest, so I'll start with the small, counting from 1, 2, 3, you get 1, 2, 3, and then what happens is each of these numbers, this is just sort of a way to remember them, we're going to get the square root, thinking of these are from the right triangles. So it's square root of 3 over 2, square root of 2 over 2, and square root of 1 over 2, which is still just 1 over 2. Y's go in the other opposite, so they go from down here, they go from smaller to larger. So we count this way, 1, 2, 3, and again, because of the right triangles, we get square root, square root. I'm not going to put it here, but there would be a square root. Square root of 1 is 1. Okay, so x's are the cosine. So if you want to, you can make a little table, 30 degrees, 45 degrees, and 60 degrees. Cosine is the x, cosine of theta, and the sine is the y coordinates. Okay, so 30 is going to be square root of 3 over 2, 45 is going to be square root of 2 over 2, and 60 degrees is going to be 1/2. Sine of 30 degrees is 1/2. Sine of 45 degrees is square root of 2 over 2, and sine of 60 degrees is going to be square root of 3 over 2. So kind of another way to remember it. Or again, just have this table ready for you yourself to do these. Okay, so sine of 45 degrees, sine of 45 is going to be square root of 2 over 2. So we get that c divided by square root of 2 over 2 is equal to 6. Now I didn't get all the way to sine. 90 degrees is here. The y coordinate of this point is 1. The x coordinate is 0. And so at 90 degrees we get cosine is going to be 0, sine is going to be 1. And I guess there's one more I could have snuck in here. 0 degrees. Let me move this part up. Cosine is going to be 1, sine is going to be 0. Okay, and so sine is over 1, cross multiply, we get that c times 1 is c, 6 times square root of 2, so square root of 2 over 2 times 6, 2 goes into 6, that's 3, so this is going to be 3 square root of 2. That's what side C is. Okay, and then to do the second one, now that we've got it all set up, we won't have to go through this each time, but do take a picture of this, write it down. We're going to use this again and again because we're going to use law of sines, but we're going to use it just for the special angles. Okay, so for this one, we are going, again, we've got a 30 degrees across, and across from it is 4. D is the angle we're interested in, so let's write that down first. And that's going to be divided by the sine of 60. That needs to be equal to 4 divided by the sine of 30. We will well, we could plug them in, or we can, let's go ahead and cross multiply first. So on this side we have 4 sine of 60 degrees equals d sine of 30 degrees. And we look this up, 30 degrees is 1/2, so we get d times 1/2, and sine of 60 degrees is square root of 3 over 2, so this becomes 4 times square root of 3 over 2. And on the left side, the 2 goes into 4, so we get 2 square root of 3, and on this side we get d divided by 2, multiply both sides by 2, and 2 times 2 is 4, square root of 3, that's the length of d. And again, that's using the law of sines. Get that one. All right, so again, remember these, write them down in your notes here. This way of constructing them is helpful if you have to use it at some other times, what I teach to my trigonometry students, because we're not allowed to give them the formula for the unit circle, breaking out here. We do give them this formulas, so that's fine. Okay, so now let's take a look. Let me clear this. Let's take a look at number 9. And so we're kind of going to go backwards through this and look at several different options working through this. Actually, I'm going to do this. I'll do the law of sines. When we get to the couple that need law of cosines, I'll do a separate video. Okay. So first of all, for this one, we've got a triangle. Now notice we are not given any of the angles as being 90 degrees. So, but we are told that A is 65 degrees, C is 62, and then B, the little side, is 63. Not degrees, that's got to be a length. Now, you might think, oh, we don't have all three sides, or all three angles, but we do. So we've got an angle and the side opposite. So we can use the law of sines to find these other two. What we need is to get angle B. And to get angle B, what we know is that 180 is equal to whatever B is, plus A, which is 65, plus C, which is 62. So this gives us 127. So B is going to be 180 minus 127. So that's 53. And notice this one, they give us a calculator, so that's it's going to be handy for what we're going to do. So 53 degrees. And again, so, oh, we've already found B, so let's go ahead and put that in, the angle measure. Wait a minute, yeah, 53. And then now we need to find side A and side C. So side A, again, we're going to use law of sines. Side A is what we're looking for. The angle opposite, 65 degrees, so we'll take sine of 65 degrees. Needs to be equal to the side that we know is B, so that's 63, they don't tell us inches, meters, something, divided by the sine of its angle, sine of 53. So to solve for A, we multiply both sides by the sine of 65. This is algebra. So those cancel. A is going to be 63 times the sine of 65 degrees divided by the sine of 53 degrees. And we will use the Alex calculator and just plug that in. So 63 times sine, and we are in degree, that's the default 65. And then I'm going to highlight this whole thing and do a divide. Gives me the fraction. Put in sine of 53. Hit enter, and that's my answer. They want it to the nearest tenth, so that's 1 decimal place, so 71.5. Go ahead and enter that in while we're at it. Okay. To find C, we're going to do a very similar thing. Again, we use this law of sine, so we set up that C divided by the sine of the angle opposite it, so sine of 62 degrees. Will be equal to, let's just go ahead and stick with B. We could use the A side, we could use any one what we have information on, but let's go ahead and use B. It's going to be equal to 63 divided by the sine of 53. So notice we used it here, so we're using the same values. Just this time we're going to multiply both sides by the sine of 62 degrees. And since these two angles are very close in size, you're going to see C is going to be very close. It's going to be a little bit smaller than A because it's a smaller angle. Makes sense. It's not as open, so it should be slightly smaller. I'm going to guess maybe around 70. That's my guess. Let's see how close I am. Or 69. Okay, we'll go 69.8. Let's see how close we can get. Okay, so then again, we just plug all of this into the calculator. Sine of 63, or say 63 times sine of 62 degrees divided by sine of 53. That's what side C is going to be. Okay, so 60, let's just clear it. 63 times sine of 62, highlight it, divide, and then we do the sine of 53. And we'll hit enter. In 69.6, actually rounded up 69.7. What did I say? 69.8? I was close, but you know. Okay, here we go. 69.7. And those will be the correct answers. Okay, so this is, you'll just need to be able to use the law of sine for several of these problems. I think the next one as well, let me take a quick peek, and so that this one video will be, and I'll label it the law of sines. Let's see. How about number 8? Now number 8, since it's a right triangle, is just the Pythagorean theorem. And remember, since we've got the hypotenuse, we will square them, but we'll be subtracting 16 squared from 11 squared. They've got the calculator here. So we don't need law of sines for this one. Let's see, 7. I think that's, yeah. We did this one in class. Get everything in terms of sines and cosines and reduce. Let me know if you need some help with that, but I wanted to just kind of focus on these. This is similar triangles, so we don't need trig for this. You just have to flip this one around and get the similar sides. And then I think, yeah, this one we're going to need actually law of cosines, because we don't have this side opposite this angle, and there's no way we can get these two angles. Now you might look here and say that looks like it's 90 degrees, but since it's not marked as being 90 degrees, we can't make that assumption. In fact, since it's not marked with a little corner here, we can safely assume it is not 90 degrees. So we'll look at this one with the law of cosines, notice is we'll have two sides and an angle between them is the way this works, right? We have cosine of A, and then we've got side B and C. So we'll be able to find this side here. And then once we have that side, we'll use law of sines to get these other pieces. Okay, so, but I'll do a separate video for law of cosines. Hopefully this is helpful. I think it's long enough. Anyway, take care, and I'll do the one for cosines.